I am the Tofu Golem. Please enjoy the video.
You start by verifying components and drawing the signal path. Put the amplifier IC, power rails, and speaker on your workspace. Make sure grounds are tied. Connect the input through a coupling cap to prevent DC offset. Choose single-ended versus bridged output. Bridge doubles voltage swing, but needs matched rails. Once done, pick output transistor or buffer stage if current drive is insufficient, and position decoupling caps close to the IC. Make sure power supply can deliver peak current for your speaker load. Now build the output stage and establish correct biasing. Begin with the recommended transistor pair or output IC topology. Wire the bias network to set quiescent current so crossover distortion stays low. Use small emitter or source resistors to equalize current between devices, and thermally link bias reference to compensating elements. Once wired, include a Zobel network and snubber across the load to tame reactive speaker impedance, and place a ferrite bead on the output to suppress high-frequency oscillation that can destabilize the amplifier. Finish by verifying the output pin behavior under real conditions. Measure DC offset at the pin. For single-ended aim near 0V, for split rail aim for the midpoint. Inject a low-level sine, then raise amplitude while observing waveform, temperature, and speaker. If you see oscillation, hum, or instability, first recheck decoupling caps and a solid star ground layout. Make sure feedback path is short. As a key troubleshooting tip, add a small feedback capacitor or increase output snubber values to tame high-frequency ringing and restore stable operation.
Thanks for watching. Consider subscribing if we helped you today.